The next topic we're looking at for Survey 2 is going to be the chi-squared goodness of fit. This is a way of telling the difference between, it's telling to see if proportions of occurrences match to what we expect to have happen. In this video, I'm showing you a simple demonstration of dice. We expect a die to be fair. If we roll that die 30 times, we would expect each number to come up about the same number of times. But we also know that will hardly ever happen, or that will probably never happen, that we get the perfect number of each number each time. In this case, if I roll the die 30 times, if we divide 30 by 6, we get 5. We'd expect 5 1s, 5 2s, 5 3s, and so on. So I'm going to notice I have the expecteds right here. Okay, and we expect them all to be 5. So this value right here is when I rolled the die 30 times, I got 3 1s, I got 4 2s, I got 8 3s, and so on. I would expect 5 of them. Now, we're not surprised that we got something different, but we'd like to know how different it is from what we'd expect. So in this cell, we're going to calculate the difference. And just like the z-test, it's what we observed minus what we expected. But in this case, each one could be different. They're all the same in this time, but if I take what we got, which is 3, and I subtract what we observed, that gives the difference of how far off we were for each one. So I have minus 2, 1. I have 2 less 1s than I expected. I have 3 more 3s than I expected. I have 3 more 5s than I expected. If we add up all these differences, notice we get 0, which makes sense. They all cancel each other out. So in order to find the cumulative difference, we need to make sure they're all positive. And not only do we want them all to be positive, but we want to exaggerate the ones that are far off, and the ones that are close, we're not going to add so much to it. Well, if we square each difference, the further the difference is from what we expected, the larger that number will be. So if I take this number and I square it, that kind of gives us an emphasized difference. 3 is the furthest out. Notice as it went up to 9, but if it's only 1 off, it would be only added 1. And also this number here kind of gives us an idea of how far everything is. Well, if we were to roll the die 1,000 times, we'd expect this number to be really big, and if I did it 10 times, this number would be really small. So I have to give it a gauge, so a basis, and that basis is what we expect to happen. So if I take this number and I divide it by this number, that gives us kind of a ratio of how far off it is. So that's equal to our square difference divided by what we expected. And this gives us a contribution for each value. Okay, 2 was only 1 away. It only has a 0.2 contribution. But 8 was 3 away, so that gave us a large contribution. Now, if I add up all these together, I get my total contribution. This right here is called my chi-square test statistic.